Now let's start the last section of today's lecture. This is the closing the loop session. You already had 2 lectures about continuations. And this is the third one, and they may have some different feel about continuations. So in the beginning, we talked about continuations. We talked about redux and continuation. Remember, right? An expression is either value or not. An expression is a value when there's no other step to evaluate further. When we are done evaluating this expression, it's a value. When it's not yet done evaluating, there are 2 things. What? Redux and continuation. Redux is the first thing to evaluate in this expression, and continuation is the remaining thing. And continuation was the work to do when you are done evaluating this redux. When you are done evaluating this redux, using the value, you are going to do this continuation. That's the continuation. We learned continuation passing style, right? We implemented FAE in various ways, like interp with expression and environment way, and interp with expression, environment, and continuation. This continuation passing style. How are they different? With this version, when we are done evaluating this expression, we had to come back to do the remaining work. Because this one only says, evaluate this expression under this environment. It doesn't say anything about what to do with the value of that expression, right? But this version says, evaluate this expression under this environment. When you're done that, using the value, do K. So you do not need to come back, meaning that you do not need to grow the code stack, meaning that you can optimize the use of memory. That's called tail call optimization, right? And because this continuation is cool, its continuation is really cool, so that we wanted to have it as a value in the language, first class continuations. Let's see. So we extended this FAE with first class continuation. VCC, I'm introducing a name X, which is a continuation. Work to do when you are done evaluating this expression, right? So we extended the set of value to have continue. Unlike closure V, which is a parameter name, body expression, and an environment, continuation has work to do. What's that? It's a function, right? And we describe the semantics of continuation, passing style, continuation as first-class values using small step operational semantics, because it was really difficult to describe that in big step semantics. Just like we extended this value, to have numbers, closures, and continuations, a pair of work to do and a value stack. So value is now contains integer values, numbers, closures, and continuation is a pair of cont and stack. So back to this interpreter using continuation, when we have function call E1, E2, when we interpret E1, that could be either closure V or cont V. If it's non-V, it's an error. If it's closure V, we do the usual body evaluation. Interpret body under this environment. What is that environment? On top of the captured environment, closure V captured environment. Extend that with the parameter name with the argument value and do the remaining work. If it's a continuation, what did we do? If it's continuation, what we are saying is, given K and S, given continuation, what we are supposed to do is application. Application of what? Oh, continuation call with this argument value. Then, oops, there's another typo here. I'll fix it later. Then what do? We burn the bridge. We do not come back to the previous continuation. We just do this captured continuation work with this argument. Ooh, isn't it cool? That was the merit, uniqueness of continuation as first class value. How do we capture that? Oh, when we introduce a name as a first class continuation, we interpret the body. While interpreting the body expression B, we may encounter a name X. Then that's a signal, SOS. Oh, escape! I'd like to escape from here. Just get me out of here. Then we just call it to here, right? Just like we are done evaluating B. So interpret B. Under which environment? Extend the environment with this map, meaning the continuation X, its value is continuation K, meaning the work to do next. Is it clear? So one more time, what's the meaning of that VCC? Oh yeah, given K and S, what we are supposed to do is interpret this expression under this environment. Then what we are supposed to do is interpret this expression E under this environment. Which environment is that? Extend this environment with saying the name X is a continuation of current continuation. Okay, so we gave you this example. Again, the final exam is gonna be difficult. So that's why we are giving you exercises and examples, and I'm giving you some questions during the class. Because it's important, I will repeat this in Korean. 기말고사는 어려울 거예요. 이게 뭐 이번에 온라인 렉처건 뭐 대면이고 비대면하고 별로 상관없어요, 우리 시험은. 온라인으로 하건 해외에서 하건 별 상관없어요. 그건 시험지 보시면 아실 거예요. 그래서 근데 쉽지 않아요. 왜 쉽지 않냐면 뭐 딱히 어려운지는 또 저한테 물어보시면 좀 곤란하지만 왜 쉽지 않냐면 뭐 예전에 보던 다른 거랑 달라요. 스타일이 좀 달라요. 그래서 익숙해지는 게 필요하고 그래서 우리가 엑서사이즈도 주고 이런 이그샘플도 주고 제가 아까 뭐였지? 람다 X 이따 영어로 다시 얘기할게요. 이거 해봐라 저거 해봐라 하는 이유는 해보는 거랑 안 해보는 거랑 기말고사 시험 때 마음가짐 다를 거예요. 해보세요. When I say do this by yourself, when I say this lambda x dot lambda y dot lambda z dot x plus y plus z and apply write your parentheses, right? And compile this, translate that to mx per, and then interpret that mx per expression. Whatever I'm saying, you'd better do that. That's gonna save you for the final exam. Okay? So this is my present for you. Yet another exercise to be prepared for the final exam. 기말고사에서 당황하지 않으시려면 이거는 꼭 해보시는 게 좋아요. Okay? If you don't want to be panicked with the final exam, you better do that by yourself. Operational semantics, putting them all together. Consider the following KCFAE expression. Yeah, it's the FAE with first class continuation. And we can represent its operational semantics in this way. And if you don't get what they mean, this is the implementation that we saw today, right? There's this one-to-one correspondence. Write the operational semantics of KCFAE of the form this, using the continuous semantics of the form this, which denotes that V2 is the result of continuation kappa taking the value V1. This is a typical problem of the final exam. So let me repeat this in Korean and move on. 파이널 exam 문제가 뭐 쉬운 것도 있고 어려운 것도 있을 수 있는데 이런 식으로 나오는 게 매우 전형적인 우리 중간고사 아니면 기말고사 문제예요. 여러분은 중간고사를 이런 스타일로 안 했기 때문에 기말고사에서 매우 당황스러울 수 있는데 그래서 미리 해보라고 하는 거예요. Our usual problem style is this. In midterm exam and final exam, there could be relatively easy problems and relatively difficult problems. Yeah, but in the usual semester, students already have that experience with the midterm exam, but you guys are not. So I'm giving you these problems to you so that you can be better prepared. So for a given expression, this time KCFAE, we gave you this syntax and we gave you this domain, and the problem statement says write the operation semantics of given language, and we already gave you this form, right? And we also give you this samples for this because there are 1, 2, 3, 4, 5 kinds of continuation. You are supposed to write down rules for 1, 2, 3, 4, 5, right? We already gave you the first and the second semantics. Write down your semantics here. You'd better do that by yourself. This version, the sooner than later. 이거 미루지 말고 빨리 하는 게 낫겠죠? 그래야 물어보기도 쉽겠고. Another thing is that in the final exam, you may see some weird language, whatever I call that, because you've never seen that language. We came up with a new crazy language for the final exam so that you can see growing language, or you can be, familiarized by yourself with when you have a new language, how you can understand that language. So again, this is my present for you to be prepared or familiarized with this kind of problem. And this is the last lecture about continuations. And now, after all that, we are going to talk about garbage collection and the brand new beginning of type system.